that when students are not harvesting and cheating, that they are actually practicing one of the things that has been a central claim that MOOCs help with, which is mastery learning. And Steve Ritter is here to present on behalf of his research team with that. So take it away. Do you prefer to be mobile?
No. I'll speak loudly.
But for recording purposes, you need to be near some mic. So
all right.
Wander around.
Yeah, then I'm going to wander. I might wander. Okay, I'm Steve Ritter. This is work that I've done with Michael Udelson, Steve Fensale, and Susan Berman about how mastery learning works at scale. And I think it's kind of nice to come after today's keynote speaker because I think in some ways we're thinking about the same issue, which is how do you make classroom education more meaningful and more effective, although we're coming at it from very different angles. I think he was saying that what we need to do is fundamentally change the education system, and what I'm going to talk about is how do we work within the education system that we have and the schools that we have and make them more effective, and in particular, so in this kind of factory model that we're talking about, adaptive learning is about giving different students different educational experiences. But schools are set up to give students essentially the same educational experiences. They're being held to the same outcomes. There's a lot of timing parameters, like the fact that you begin a class, everyone begins a class at a particular time, the class ends at a particular time, the set of topics that you're supposed to learn in that class is the same for every student in that class, the amount of time allocated to each topic is typically the same. So all these things mitigate against using adaptive learning in your classroom. So when you have instructor expectations and practices that are built around that factory model, student expectations and practices about how that factory model works, and institutional structure and requirements, like the dates that exams are given, for example, so you need to teach everything before the exam comes. How do you manage adaptive learning in that environment? So that's what I'm going to be talking about. To start off, for people who don't know, Carnegie Learning spun out of Carnegie Mellon University about 18 years ago, believe it or not. And we're a publisher of math curriculum in middle and high school. We also do some business in higher ed, developmental math. I'm going to be talking about middle school math in this case. And one thing to understand about our primary products is that they're used as core curriculum. So we publish software, textbooks, and we also provide professional development and training to teachers. So we're kind of taking the whole kind of structure of a classroom and helping schools implement that. And our customers are schools in the United States. We recently completed a large-scale randomized field trial showing that our curriculum was effective at scale relative to traditional instruction, textbook-based instruction. This was done by the RAND Corporation on our Algebra 1 curriculum. 147 schools were randomly assigned to either use our curriculum or to continue using a textbook curriculum. And what you can see is the gain scores over the year were significantly higher for students using our curriculum, and even higher when you later analysis did principal stratification to isolate students who completed more than the median amount of curriculum within our software. So two things that are really interesting about this study, besides the kind of positive results, are the fact that schools participated in this study, the random assignment, the schools were in the study for 2 years. There was no significant effect in the first year, right? So the product doesn't kind of magically produce results, right? The first year there were no results, and the second year there were positive results. So something happens in the implementation between first and second year. And so one of the things I'm going to talk about, I can't relate the data I'm going to talk about specifically to what happened in these schools, but we're trying to look at what implementation factors, beyond the presence of the materials and the training that we give teachers and all that kind of stuff, what really produces results, right? So the first to second year result is an example of that, and the other one is usage. So the primary analysis was what they call an intent to treat analysis, which means that schools who were assigned to use Cognitive Tutor, our curriculum, were considered to have used Cognitive Tutor even if they didn't use it, right? The quality of implementation varied from just about nothing to excellent implementations, but they all count in that group, except for this bar, right? So that bar is kind of trying to say, well, what do we do about actual usage of the curriculum? Okay. A model implementation in our classroom is blended. Students will typically use the software about 40% of class time, 2 days a week. They'll use activities in our textbook and collaborative activities the other 3 days a week. And you can think of this as kind of parallel tracks. So the textbook activities and the collaborative activities are being done kind of paced by the teacher, right? The whole class is doing more or less the same thing on any given day, whereas the software is self-paced and mastery-based, and so students are working through the software at their own pace. The software is judging their mastery and moving them from topic to topic as they move along. So here's what it looks like. The middle school implementation of our software is called MATHia. You can see up there the string of islands. Each of those islands you can think of as a mathematics topic. The first island is open. The other islands are locked. When you master the material in the first island, the second island will automatically unlock, and you as a student will move to the second island. Right? One thing that's important to understand, though, is there's a teacher management tool, and with the teacher management tool, teachers can lock or unlock islands for the students. Right? And that, I think, is a feature of probably every deployed adaptive learning system, and if it isn't, teachers will work around it. I know this from experience, right? So if the teacher wants everyone to work on Island 3 today, they will figure out a way to do that. The kind of activities that students do, if you look on the upper right, they're multi-step problem-solving activities, so they are typically not getting or never getting kind of multiple choice questions and things. They're drawing graphs or plotting things on a number line or answering questions and those kinds of things. So there are multiple steps to solve within each problem. And then we're judging mastery via Bayesian knowledge tracing. So we have a set of skills within, you can think of it as within each island, there's a set of skills or knowledge components that students need to demonstrate mastery of, and they demonstrate that using Bayesian knowledge tracing, or our system uses Bayesian knowledge tracing to judge whether they've mastered. So mastery learning has a long history. Some people point to Bloom had a very influential paper in the 60s. Keller did as well. But I think it's safe to say certainly people were talking about mastery learning well earlier than that, and I think it's probably certainly true. It seems almost so obvious that Socrates probably had a notion of mastery learning at some level, right? Fundamentally, it's about making sure that students master the prerequisites before you move them on, related to Vygotsky's zone of proximal development, clearly. One of the things that's really interesting in the mastery learning literature in the 60s when I went back to read it is the emphasis on the fact that every student can learn. So mastery was not just a statement about cognition, but it was a statement about a belief that if we only gave students enough time to learn everything, they could learn everything, because a lot of students are in a situation where they're not given enough time to learn, and so they don't, right? So it's as much kind of a social belief as a cognitive belief, at least in some of that literature. And there have been a number of reviews of it. This is fairly older, but strong evidence of effectiveness. I should say the other thing to point out is mastery learning and the theory of mastery learning was developed without computers, right? And mastery was often done at a class level, not even at an individual level. So one of the things that computers do for us is they handle a lot of the logistics that would be really hard to do without mastery learning. Among them, doing individualized mastery learning like adaptive systems do. Just keeping track of that at an individual student level is very difficult without a computer. And also it allows us to do things at the knowledge component level. So we're not just judging mastery at a high-level topic, we can judge mastery at fairly fine-grained skills. So that's one of the reasons why I think one of the potentials of adaptive learning systems now is that they can handle a lot of the complex logistics that would be really hard to do prior to computers. One way to think about one of the effects of mastery learning is that it creates a consistent level of challenge for the student. So this is data that we published about 9 years ago. The x-axis is time. This is for 88 geometry students who use cognitive tutor in one school, and you're looking at percent correct. So you can see when you look at each action they take, so remember these are like multiple step problems, so it's not problem level percent correct, it's action level percent correct. But if you look at all the actions that they take over time, the percent correct is roughly constant over time. Okay? And so that's good news, right? They are learning, but as they learn, we're giving them more difficult or at least new skills and knowledge components to demonstrate. And so if we're doing that right, we're trying to keep the level of challenge about constant across the school year. And this is across a full school year. Okay, so let's look at what it looks like in practice. So here's a very complicated set of graphs, but I'll try to explain it. These are bar graphs. The x-axis, again, is time. Each bar represents 1 week during the school year. The height of that bar is the average time per student that they spent in the software in that week. All right? And each graph is a particular class. Okay? The colors within those bars each represent a different mathematics topic. Okay? And the percent of the bar colored represents the percentage of time that the class as a whole spent on that topic in that week. Make sense? Okay. So in the top graph, you can kind of see that, week 1, everybody was working on topic green, with maybe 1 or 2 students got onto the purple topic. In week 2, more of the students were working on purple, but most of the students were still working on green. In week 3, fewer green, a lot more advanced to purple. Some of them made it to gray, and so on. So you get this kind of nice wave pattern at the beginning of the year as students advance from one topic to the next, right? And then you see, back by December and into the end of the school year, you start to get a lot of colors in every week, right? Because now the students have really spread out and they're all working on different topics. Okay? So that's one class. Here's another class in the same school district, and you can kind of see it's blocked, right? We're all going to work on gray week 1, 2, and 3. Then we're going to finish up on gray, and we're going to spend most of our time on yellow. And then the next week we all do yellow, and then we're still doing yellow, and we start on purple, and we move on like that, right? So you can just see the class kind of marching along at the teacher's pace. Okay? So that's just a visualization of what these 2 different classes who have the exact same product and are in fact in this exact same school district do. Okay? And these are hand-picked cases. Most of them are messy combinations somewhere in the middle of these things. Okay, so this study is, the data they're going to talk about does come from a single large urban district in the southeastern United States, where they have 49 middle schools who are implementing our MATHia curriculum. In about 280 classes, it's about 11,000 students. And we selected this district partly because of their size, their regular users, I would say, as a whole, as a district, they're implementing pretty well. But there are very varied implementations at different schools and among different teachers within this district, as always happens. Okay? And we're particularly looking at whether teachers are kind of opening up these islands, whether they're violating mastery learning. I'll sometimes talk about it as the students violating mastery learning, but it's really the teachers enabling the students to violate mastery learning. So they're opening up topics, encouraging students, sometimes requiring students to do topics that the mastery learning algorithm would not have let them do, right? Because they haven't been judged to recognize the prerequisite. And basically what we're using as a proxy for the teachers opening those islands, because it's a little complicated, it's explained in the paper, but there's several ways that they can kind of do those things. But we're looking at how many topics were started and not completed is our proxy for moving. Yeah, did you? Yeah, it's, I'll have to make up, well, yeah, truth is it varies a little bit because this is actually across 3 different grade levels and stuff, but you can think of it as about 40 different topics, and I'm glossing over a little bit. They're not technically all separate islands. There's a different level of hierarchy, but it shouldn't really matter.
Something like
Yeah. Yeah, you can think of the topics as kind of the major standards in a math class, in a middle school math class. So overall, about 21%, and this histogram is by class, so this is 280 classes. You can see that about 21% of sections, the median is 21% of sections are left unfinished, meaning that students have been moved on prior to mastery. Okay? And you see there's a number of classes where that very rarely happens, and then there's a long tail of classes where mastery learning is violated very frequently. Okay? But overall, I think that's a pretty high median. That was a little surprising to us. So let's think about why teachers do this. And there's a number of arguments that I do want to kind of be fair about, saying there's a reason why we built the ability to open islands into the system. Okay, good. So you might, as a teacher, not believe that mastery learning is the best approach for your students in the first place, right? You might believe that there's a measurement issue. So I, as a teacher, know that the student knows this, even though a cognitive tutor thinks they don't. I'm going to move them on. You might have this optimization theory that says, hey, you know, teaching to mastery is wasting a lot of time on one topic. Maybe it really is better overall to kind of move them on in favor of mastery. So there are some kind of theoretical instructional arguments about it. Mostly, I think, I've been thinking about these kind of structural barriers in the school environment. So, as you saw with the multiple, if you think about what a teacher's experience is when you have all those different colors, right? You have every student in your class working on a different topic. What that means is a student raises their hand, they might ask you about the quadratic equation, they might ask you for the formula of a triangle, right? You have to be prepared to teach every topic in your curriculum. So in some ways it makes your job harder, right? You have to be more prepared to address lots of different topics. School systems impose lots of requirements on you. You have pacing guides, you have benchmark exams, you have scheduling requirements, which all assume this kind of factory model. And finally, mastery learning works best when you give students the time to learn. Well, that means that the students who need more time have to be given more time, right? And so that you can, I didn't mention, students can, of course, use the software outside of school. Sometimes that's more practical than others, and some teachers worry about whether they're able to give students more time. Okay, so given those potential barriers, let's look at what the data says. So we did a median split on classes based on how often they were violating mastery for students. So the red bar is the classes where they are following mastery, and the blue bar is the classes where they're violating mastery. And the x-axis here is time in weeks. So what you see is the red bar is very similar to that graph that I gave before, right? The level of challenge, and the y-axis is error rate, number of errors that they're making normalized per problem per hour. So the error rate is relatively constant for the classes where they're generally following mastery. For the classes where they're not following mastery, the error rate is higher, and it gets worse over time. Why is that? Because over time, the students are missing more and more prerequisites, right? So they're getting more and more lost as time goes on. And we also did a split by student performance. So we looked at student performance on the first 2 exams in the course and used that as a proxy and divided these students into high-performing and low-performing students, right? And again, you see that violating mastery differentially hurts the low-performing students. Why is that? Well, we think it's because teachers are seeing this as a structural problem, right? My problem is the benchmark exam is coming up, or I intend to teach quadratic equations today, and everybody's not at quadratic equations, so what do? Well, some kids are at my pace or ahead of my pace. They're fine. I'm going to leave them alone. But some kids are behind. I'm going to move them up, right? So it's the lower performing students who keep missing their prerequisites, right? And then, again, get more and more lost as time goes on. Okay. Little note about causation. So it is true that classes who have more poor performing students violate mastery more often, right? And students who are poor performers at the beginning of the year have mastery violated for them more often, right? So it's not entirely that the teacher's decision to kind of move students more frequently is causing students to be lower performers. It's kind of this vicious cycle, right? The low performers get moved more often, then they do worse, then they get moved more often. Okay, so let's talk about what we need to do to scale adaptive learning. So I've been kind of interchangeably saying adaptive learning and mastery learning. Technically, you can do adaptive learning without mastery learning, but most adaptive learning systems are trying to figure out what students know and don't know and giving them an experience that's relative to their level of knowledge. So I think this kind of thinking is applicable to all kind of adaptive learning systems. Fundamentally, any system that really wants to individualize instruction at anything smaller than the class level. So we do see that mastery learning is effective, right? And that we are reasonably at least judging students' abilities and presenting the next topic at the right time, which is as evidenced by the relatively constant error rate. Teachers don't always recognize the value of mastery learning. And so one of the things we're thinking about is how can we build reporting systems that tell teachers about this, right? That make it real to them about their own students, right? The other thing that I think is really important is I do think it's fair the teachers need to use their own judgment, right? This can't be imposed on them. It won't work anyway. So there is a balance between telling teachers, hey, this is generally the best practice to do, but there may be exceptions and it may be up to you to decide special cases and other reasons why maybe you really do want to violate mastery learning. And the truth is, like, even legally, teachers are worried about if you get to the end of the year and you've only taught pre-algebra in an algebra class, you know, you're going to have some very angry parents and you may get fired, right? So there's balance, there's things that you need to do in this environment to deal with it. And fundamentally, like, one of the fundamental problems in adaptive learning always is how much do we prescribe versus how much do we suggest or recommend or nudge, right? So big issue we need to think about. And then finally, there is this alternative school model, right, which is kind of what we heard about in the keynote, right? This model would work better if we really didn't have, you know, classes that lasted for a school year, right? If you're able to finish Algebra 1 in 6 months, finish it in 6 months and let's move on, right? But so there are alternative school models out there, some of them being implemented, and in some cases that's a thing that would make this work better, but I think right now we're thinking about the schools that we're in. Some other things that we're doing specific to this work is we're getting external test scores, so we want to look at all the measures that I've talked about are internal to our system. We want to see whether these mastery learning violations correspond to performance, for example, on the state exams and things like that. We want to model prerequisite. So maybe there are some prerequisites that you can skip and other ones that you really can't, and that might help us inform teachers on how to best navigate this balance between the school environment and mastery learning. And then finally, maybe we can do some experiments to look at maybe we do implement a version where teachers are not allowed to move students or strongly discouraged or something like that. Okay, so thanks.
Okay, so we still have some time for questions.
Thank you. Hi, very interesting. I wanted to ask you, when you think about designing adaptive mastery learning, there are a couple of parameters in the definition of the system you can tweak from your system, from where you are, that would really help the problem of the teachers that is generating this mastery learning. One is, you can imagine mastery learning, but you can only do the software, the individualized work in the classroom, and that is a constraint of how many hours you can spend per time that basically creates a spread of where the students are. But you can imagine tweaking the parameter in which you say, well, you have to have mastered by this time, you just have to go home and do more hours.
Yeah, so that's a model that we recommend that teachers implement, but they have to tell their students, right? Hey, you know, you need to finish the third island by this date.
So they're constrained on that. And the other tweak of the parameter is you identify this problem that the teacher has to go and be able to teach 5 different things. But I want to separate kind of teaching new material or preparing these collaborative activities versus you're working with the software. One of them creates the problem, the other one doesn't. So one parameter you could tweak is what share of the material is taught by the teacher versus is taught by software. If it's taught by software, then this doesn't become much of a problem. So why is all of the, in your blended classroom model, why is all of the teaching in that way?
Yeah, maybe I didn't say that more clearly, but there's a classroom environment where the teacher is leading the class. When I was talking about the teacher being called over by the students, that's when the students are using the software. So it's just on any given day, the students are doing different things in the software because they've advanced at different rates, right? And normally a teacher can prepare for a class by saying, hey, here's, like if you're just going to do a lecture class, you say, here's what I'm going to do today. I know exactly how the day's going to work, and I just plow through it. If the kids get it or not, it's their fault, right? That's kind of the traditional lecture-based format, right? But in this format with the software, the students are calling the teacher over, so the teacher really needs to kind of understand the math well enough to answer questions.
Could I ask you to answer your question to the mic so that we can capture the answers too?
All right.
Hi, Amy from Carnegie Mellon. Curious, so you presented these potential reasons why this might be happening, varying from teachers don't believe it works, et cetera, et cetera. And then I thought you were going to tell me what the teachers think. What do the teachers think? How does that affect your design? And do you potentially work with them to offer alternatives like super intensive small group sessions with the students who are way behind, or can you come up with other models that or maybe you have to address their beliefs that mastery learning doesn't work.
Yeah. So we haven't done a formal survey, so I'm not comfortable really saying, but I would say in conversation, and we could definitely collaborate on that. I would say informally the structural reasons of what they always come up with. But that's what teachers say also. And I worry about whether in the back of their minds they're like, yeah, you know what? Sure, I have to respond to these benchmark exams and these other kind of pacing guides and stuff. But in fact, I'm kind of happy that I have to do that. Do you know what I mean? Because it fits my model of, how I want to teach anyway.
Hi, I'm curious. Colin Fredericks, Harvard. I'm curious as to how the grades in the classes were determined. Was it number of modules mastered, or was it a separate external exam?
That's a good question. I don't actually know the answer. So typically, I will say, and I'm almost sure that it's true in this district, that part of your grade has to do with what you did in the software, and part of it has to do with other exams and things.
Okay, one more. I'll.
Hold on.
WBC, did you do some median split or something to see low achievers, adaptive versus non-adaptive?
Yeah, that was the last graph where we split them based on their first 2 test scores. So
right.
So yeah, the low achievers both get skipped or get pushed past mastery more often, and they're the ones who are differentially affected by the fact that they're.
Oh, okay. I didn't read this table. Okay, thanks. Sorry.
Okay. Anyone else? Well, okay, we do have time for one more. So.
I'm just always nervous. I'm going to run out.
I'm Justin Reich from MIT. I don't have a question, I had sort of an idea. In terms of interventions at the end, one of the things you proposed was doing some kind of intervention before people start doing the violations. But could you imagine some set of interventions sort of after the violations? Like you're in a district and you can predict that half of the schools half the classrooms will start violating, half won't. Of the half that do, you send in some set of supports and see if like there are moments in which you can get people to sort of change their practices or other kinds of things like that.
So yeah, that's a great idea. In fact, we already do that.
Okay.
But not very effectively, apparently. Because we do, this is a large district. They have, math coaches and administrative people who are very well aware of this issue. But teachers are relatively autonomous, and so, yeah, any ideas about how to do that more effectively, that'd be great.
Okay, with that controversial suggestion, let's thank the speaker.